Hi, in this example, we're going to take two sets and the universal set and determine how many elements are in one of the sets. So let's go ahead and just take a read here. So the universal set is S, and A and B are subsets of S. A contains 99 elements and B contains 16 elements. Sets A and B have one element in common and there are 30 elements that are in S but not in A nor B. How many elements are in S? So recall that S is going to be all elements, including its subsets. So if I just drew like a little Venn diagram here, and two sets inside, right? And this is A, and this is B, and this is S. So S contains all the elements inside, including A and B. So let's write out what's given to us first. So we do know that the cardinality, right, the number of elements in set A is 99, and the cardinality in set B is 16. And the fact that it says that A and B have one element in common, that means that this intersection here, that they overlap with one element. So the cardinality of A intersection B is equal to 1. Okay, so if their common element is 1, that would mean that if there is 99 elements in A, that just here alone would be 98 because the entire set A would be 99, but they have one element in common between A and B, and so this one would be 98. So then let's think about B. If there is a total elements of 16 in set B, but one of them is shared, that means that the number of elements solely just in B itself, meaning not included with the intersection, has to be 15. So visually you can do a Venn diagram or you can do a list with some formulas. I'm going to do both just so you can see both, but you only need one or the other because really all you're doing is trying to just get the answer. Okay, so the next part states that there are 30 elements in S, and then here's the kicker, but not in A nor B. So that means that there's 30 elements that's not included in this union. So the union of A and B, this entire piece, is not included with the 30. So the 30 elements live out here outside of the union of that set. So we can identify that in a different color, 30. Okay, and then how we would write that is if we want to include all the space outside of A union B, then that's just the complement. So the number of elements or the cardinality of A union B complement is equal to 30. Okay, so just from the Venn diagram, we could see that the number of elements that are in S total is going to be the sum of all these three numbers. So right away, we can kind of see that, okay, I'm just going to add 30 plus 15 plus 1 plus 98, right? But if you wanted to use some formulas, we could use the formulas given in the textbook that n of a complement is equal to the number of elements in the universe minus the number of elements in that set. So if I have the number of elements in A union B complement, which was given, then that's just the number of elements in U minus the number of elements in A union B. Okay, so in this case, I'm looking for the number of elements in U, which is really S. right? I should rewrite that. So this means that I have this information, right? That's 30 equal to that cardinality, which I don't know, minus the number of elements in A union B. So in A union B is all this here. So we'll have 98 plus 1, which is 99, plus 15. So then we get 30 equal to n of s minus 114. And then if I add that over to the right side, I get the cardinality in the entire universe is going to be 144. But we could have said from here, if I wanted to draw it, that, oh yeah, I would have just added these all up anyways and got the same answer. So if you want to do, and let me note this, so this is like number one way, that's okay. And then this would be the second way you could do it. It's just really up to you and at the student's choice.